So many thanks for joining the session. What to learn from Kubernetes war stories. As Tommy said, my name is Van Schubert. I actually work with clients across the board and try to understand where their challenges are and naturally experience a lot of tough situations that our customers are in, especially if we start engaging with them and understand what their journey has been and where they actually want to be, and how we can help them. Actually, I think we are ready to start. As Tommy said, if there are any questions, just put them in the chat. Also, if you've got any stories to share yourself, feel free to actually do that in the chat as well, or we actually can see if we can open up the microphones at the end. I don't know if that works, but we'll actually do that more in the future to also let you all speak a little bit more. This webinar was triggered by feedback from a previous talk where a head of infrastructure asked me if he could share more examples, what went wrong, so they actually could learn from that. And we actually always take this feedback very seriously and appreciate that feedback, because then we actually can really cater the content to the needs of those who are actually interested and attend these webinars. And I actually went through and gathered examples. I clustered them in 5 or 4 different areas, and basically I just picked across the board from scope to people to technology and operations, what I actually gained from other or from conversations with organizations, and naturally from working together with clients for over 6 years now in the Kubernetes space, which is quite a significant time, especially operating Kubernetes in a scalable fashion. I naturally will not name companies, but I will describe them so you get an idea of the size and the industry, and also the associated challenges. Also I wanted to say just a short word on the level of detail I'll be going to provide. I saw a couple of SOEs sign up for this session. That's really great having you. My goal is also to actually make you, since you actually are those that will feel the pain of the first, to actually feel that you're not the only one, and also give you examples what to watch out for in the future. But what I actually will not do is go into a lot of detail about about postmortems, things we observed, and stats on graphs on performance, and let's say technical issues we ran into, if it's DNS or affinity or rules or whatever, and what fixed or what helped us fix this, and the tools we use for that. This is actually covered by other speeches. There's one by Puya, who's our product VP of product, or even a friend of ours at Zalando, Henning Jacobs, did a great talk at Container Days, or KubeCon. So that's actually covered more in those talks. We actually do about 500 to 600 postmortems a year. So if you actually want to dive into any of these stories, please reach out to me, and actually I'll set up a call with someone who's technical and actually will go into that detail, and help you figure out if there's any challenge you're faced with that you actually would like to discuss. I'll actually be touching the areas on a higher level, and going through this presentation, talking about let's say high level challenges that I've seen, and naturally examples of where that actually either worked or failed. So, as I said, there are different drivers to success for Kubernetes. First, naturally, if you actually look at the scope, you actually need to have a project that is important and urgent, and that will contribute to their business value. So the scope is very important. You also need people for that, which is the knowledge, the experience, and naturally the staff to drive Kubernetes forward. Typically, that's an area that is underestimated. So we'll actually spend a little bit of time working around the challenges in that area. Naturally, then technology, which not only includes Kubernetes. Actually, I think I don't even have Kubernetes examples in there. Actually, I'm more focused on the, let's say, on the technology around Kubernetes and how actually that can create challenges and especially operations, which basically takes you all the way from planning to delivery. And that's something that we'll actually be going into detail. And I've got 3 to 4 examples per area. And and let's jump in. I would say start off with scope. So the first slide is about boiling the ocean. This is a case where we encountered a fast-moving consumer good producer, and they actually hired a new CIO. And the goal was for the CIO to transform the organization and have them focus and develop digital products. And the enterprise architects were then tasked to analyze the application landscape, and I think they analyzed 3,000 applications and identified about 1,800 applications that they actually wanted to move to the cloud, including monoliths on Windows servers. And the infrastructure team, it had been the bottleneck in the past. So every time the development teams wanted something, it took them 2-3 weeks to provision something. They basically were perceived as the bottleneck. And so the CIO tasked them to build a self-service platform or portal where developers could go on and they could basically put everything together in a shopping cart, and then it actually hit a button and the automation will provision everything in the background. And while actually that eventually makes sense, they actually had 4 teams that were in dire need of moving onto Kubernetes or their workloads onto Kubernetes quite quickly. But by the time they actually had this POC ready to show them what it actually would look like and if it fulfilled the requirements, 3 teams already had decided that they'll go and do it without Kubernetes. And 1 team already had deployed and started operating Kubernetes themselves. So what actually that created for the infrastructure organization is that they actually had to then take over that Kubernetes and run it for the team, being very far from what they actually originally had planned. They're still, I guess, developing this portal in the background, and hopefully they'll be migrating everything. But basically, that's where reality defined and speed defined what areas you actually need to provision in the future, and that's not the way it should be. So if I want to give some recommendation here, it's actually to start iteratively with teams and make sure that you actually then build something that they really need, build it very fast, step by step with the team, and then evolve from there. If you actually start with with the whole story, you actually will very likely will be a big challenge to get and to have everything ready in time for your teams to consume this. And it's also very likely that you will find out that once you actually have deployed something and provided it to the team, it doesn't really match the expectations. So so that's something actually to watch out for, and make sure that that you actually really deliver something in a very, very short period of time to the team what they actually need. Another example is are you moving elephants? So this is a story that I also covered in the story above, but running into many companies and observe when talking to them is that they actually want to move their monoliths to Kubernetes. And in this case, I was talking to a financial institution, decided to move their monolith into a container and then onto Kubernetes first, and then re-architect that when that actually was in the environment. And if you haven't done that so far, it's actually quite impressive what you can put into containers and run on Kubernetes. So the approach seemed fair, but it actually came as it had to come. They actually extended the monolith and they never got around re-architecturing. So currently it runs on a single pod in Kubernetes, and is is neither scalable nor can you actually exchange the underlying infrastructure, update it seamlessly without moving the application. So in general, it's great if you actually support your teams with what they need currently, but here in general, the learning is you need to incentivize the right behavior. And there's one trick here, for example, that one of our clients applies, which is they actually have to find a time frame, a fixed time frame every week, where they actually just randomly restart the nodes. So they actually roll the nodes and make sure that basically the applications need to be able to handle that, and if it breaks something, it's naturally on the test systems and dev systems. But if the application doesn't handle that very well, it actually forces the development teams to take care of that, and that actually pushes the motivation and the focus onto the right area that help you do your job a lot better, because you're basically making up for what the development teams actually didn't take care of. Let's look at the third example. Just trying to switch here. Do you actually focus on setting on what sets you apart? So in this example, we actually encountered a huge internet service provider. They actually run their own data centers, and they actually build and operate their Kubernetes for a large development team all by themselves. And it makes a lot of sense. They're an ISP. They actually might even provision and run Kubernetes for their customers. So they actually got help from an external consultancy that built up the stack and the pipeline for them. They also then went out and hired, I think, 5 developers or engineers to cover operations for the Kubernetes stack, and also naturally incoming requests. And within a couple of months, actually, to that extent, was very successful. They actually got swamped by development teams with requests about new functionality, new apps that they actually want to install that actually would cover certain services, and basically extend the automation for naturally multi-namespace, multi-cluster management. So they actually basically were in this situation: what do we need to focus on, and how can we provide the services? And so they actually basically are in a situation where they need to make a choice very shortly if they actually want to hire another 3 to 6 people. This will probably take another 3 to 6 months, plus onboarding, plus training. So experienced people aren't that easy to find, as you may know. And so they're in a really tough spot. What should they do? So we basically, they actually need to think about whether they want to bring someone on board who actually can manage the standard Kubernetes stack, or if they actually just and then take care of the needs of the development teams, or if they actually get someone on board to actually take care of the development needs, which then basically puts the question is what way do they want to go forward? How do they want to retain and motivate their people? How do they actually make sure that automation is driven forward in the right way, and that not all requirements from the development teams are implemented, but really prioritized in that way? Or they actually can also then keep the software development teams waiting, and that's something that is a very tough choice. So actually, the recommendation here is if you're too busy running this the platform, you actually you're the roadblock in terms of transformation, and you're actually keeping your development teams from getting the benefit out of the platform, and that's where we actually say it's you basically flush the opportunity down the drain. in terms of the all business, the potential that that cloud native can bring you to the organization, and that actually halts and corrupts the whole transition process, which actually is a major challenge in this space where transition is uncertain in many ways, anyways. So yeah, and it actually, in another way, it actually you actually need to keep make sure that your clusters and your automation stays very stable, because if not, then it creates naturally a people problem. And that actually brings me right to the next passage, which allows us to focus on people. So the Kubernetes is a platform to build platforms, so you need the right people who have the experience and can anticipate the size of the team and retain the experts to actually drive this evolution of the platform forward. You actually start small, you develop it further, and there's constantly evolution in this space. So you actually will need to think about how you can set up your organization in a way that then handles all the incoming requests and the operational activities that need to be covered. In this example, I want to talk about a company, a mid-sized bank, and they actually, I would describe it as the way is like, some things could look on paper, look good on paper, but they're very painful in practice. And this institution actually basically was working together with a consulting partner who actually provides a lot of training courses and offerings around a certain public cloud provider. And they actually did a fantastic job in, basically specifying all the clusters and all stages. Every team actually had 3 different stages, and and basically what they developed is a concept where this actually wouldn't cost or would they actually try to cost optimize this setup. So they put everything into a single VPC to avoid traffic cost. And this, however, means if if you actually run into a security incident and you cannot cut off your VPC, and you actually need to replace the clusters, you actually will experience downtime, and you can't really cut it off and analyze the situation to understand the impact and how to prevent that going forward. So from our end, we've been there. We actually saw a company that basically did an upgrade, I think probably 2-3 years ago, to the latest Kubernetes version, and they actually ended up having a crypto miner on their pods. Being able to cut that down and or cut it off and then analyze it gives you the potential to really to assess the situation properly and also finding the best way forward. And unfortunately, in this situation, they actually also had to get their concept audited. So they actually went through the whole process of verifying and auditing the whole concept and the whole setup, and they actually were just about to go live. And there was nothing you actually could do before the go live to re-audit the whole setup and change that. So the setup isn't wrong. I think that's one most important thing is like, many choices you can make, they are not necessarily wrong. But if you actually take different aspects into consideration, you actually will want to build for change. Because at some stage you actually will learn something new where you actually need to where you actually basically need to understand how you can adapt to this situation and be very flexible. So my recommendation is, operation experience. It's paper design for breakfast. So this is where you actually need to really focus on the technical experience that either your team has or you get it from outside. Make sure that you actually get that experience in at the very, very beginning, so you can already get started on a great path, and you can actually then develop this further and further, but you already have the right setup from the start to actually really focus on the areas and avoid pitfalls that could be easily avoided. Then the next question is, do you have time to evolve? So the company I want to share a story now. They actually started off running Kubernetes all by themselves. So they actually picked an open source project, and also they actually were able to support a rapidly growing number of development teams that actually really breathed innovation, that developed this. In the beginning, the team could manage quite well, but it became very, very clear that they were getting into trouble. They were bogged down with like administrative tasks over and over again, and they couldn't actually develop the platform further. They couldn't build out the automation that they actually wanted to build. And before they actually had made the switch to someone that actually run it, they were facing then eventually serious downtimes. And also they didn't have any resources to actually make up for, like, to go into root cause analysis and really no time to invest in automation to make sure that the downtimes actually wouldn't happen again, and that they would have the right logging system in place to actually allow them to figure out problems and challenges a lot easier. So with that having said, I think from that point of view, if you're set to learn that you can't evolve, if you don't have time to actually to really evolve, then you're actually not spending the money wisely, because then you actually will do the following, and that happened in this company. They actually were facing serious downtimes, and the platform, the development teams, actually wouldn't trust the Kubernetes system anymore. So even when they actually got a new Kubernetes system in place, it actually took them a long time to transition to that Kubernetes system, and then actually build up the trust that they actually could really get back to their innovative speed that they actually had at the very beginning of the once they built that organization. So you actually are, you're basically, again, wasting a lot of money by setting up their organization, the platform teams, very leanly. If they actually don't have 50% time to think about how to optimize, how to evolve the platform, then it's not that you can be proud of having only a few people sufficiently managing your Kubernetes environment. You're actually losing money by not going with the speed of innovation that you should be. So, and I think the third one, nope, sorry, that was too fast. The next one is actually, will your people stay? That's a situation that we encountered twice now in the last while. Excuse me. So that's where you hire a team, they build something, and then they leave. And this is exactly what happened to this fashion retail company that I actually want to talk about. They had 4 key developers on board that built something really awesome. They had a CI/CD pipeline that actually would take care of all manual work and take that away from the developers. They would just like develop the code and push it into the pipeline, and then the pipeline would take care of everything. And they actually set it up so it actually would really, really efficiently manage the clusters, and that actually worked really nicely. But then people started to leave. So there were actually people like SOEs that started to leave, and they actually basically couldn't cope with the very, very specific, the ones that were left with a specific setup for that pipeline. So they basically ended up then all leaving. I think the last one will be leaving in another 2 months. And maintenance actually just became very, very difficult. Automation was very custom, so it was impossible to find someone else coming in. And so in the end, the company actually needs to move their platform to ensure that they are still operational, and they actually can still maintain and fix it going forward. And this is their e-commerce store, so something really, really hurtful if you actually aren't up and running all the time. So here the goal is really to retain staff it's important. You actually, at the same time, by retaining staff, you actually need to make sure that you also standardize your platform, because you actually always need to think about people actually leaving the organization, finding new opportunities, and someone else needs to come in and take that over. So either standardize it or open source it. So you've got a bigger community that actually then continues to develop and take care of the code. And this is something that this company actually failed to do properly. So we actually talked about people, and actually now want to go quickly into technology and operations. So the next story is another large fashion company. And here the question is, are your apps cloud native ready? And I'm not talking about, again, I'm not talking about the apps of the customer. We already covered the monoliths. I'm talking about apps that you as an infrastructure team would install. There are actually companies out there that, and I think nearly all companies actually would now give a preference to solutions that are cloud native ready. And that's why a lot of companies actually would claim that their applications are cloud native ready. But the question is, how well do they support the cloud native principles? That actually only becomes clear when you actually really run it in containers in Kubernetes. And in this fashion company, they used the technology for an API gateway that they actually have known in the past and used in the past. And that company also claimed that their solution was cloud native ready. So when they actually moved to the containers, they actually found out that it worked. Everything worked fine. The only problem that they actually had is that if they actually wanted to scale up or roll nodes or bring the service back up again because it may have failed, it would take them more than 15 minutes to do so. And if you actually have an hyperspace environment where you actually basically scale up and scale down quite rapidly because of customer needs, this is something that actually can really break your neck. And that actually is not only this company, there are also other companies that basically have made experience where there are single replica applications, and there are many, let's say, challenges that you actually need to cover when you're talking about cloud native. So yes, it actually can run in containers, but it might not be cloud native ready. What we actually did is in the selection process, we actually set up and tested this process very intensively. And we actually also found found a good replacement, but not all assessments actually work really well in that respect. So the same company actually made experience with the security app that the security department wanted and selected and required them to run in their containers. And it's a cloud native ready company or cloud native company in general. Basically all the problems that you actually seen above wouldn't apply to that company. But what they actually basically had challenges with is managing the complexity of the many microservices that the solution was running. And this is something that you probably only discover at scale. In general here is like, don't take cloud native for granted. It's something that vendors actually need to claim, and they need a lot of time to re-architect their solutions. So it's very, very normal that they actually have difficulties, making a differentiation between what is really cloud native ready and what isn't. But then also the point here is really it actually needs to fit your cloud native use case, because if you've got an application that is doesn't restart and you don't roll a node once a month and you actually it takes 15 minutes to come up and your service isn't customer facing, then actually that might not be a big issue. But for others like e-commerce shops or whatever it might be, and that's where the big difference comes in. Then the next point that we often see is the question that goes with that is your cloud native stack modular enough? Some decisions are just hard to make, and vendors and technologies are very fluid in the cloud native space. There's a lot of innovation going on, a lot of new vendors, a lot of new technology coming up that might be better in one way or the other. And it's therefore important to really build up the stack in a very modular way, not only to avoid lock-in, which is a key element that you need to take care of, but also exchange technologies when alternatives actually seem to be better, either for your use case or in general, seem to be the more pressing ones. And with some apps, like security, it might be easy to fulfill, like scanning containers or whatever. But in some use cases, you actually might be using proprietary technologies or extensions, and that can be monitoring solutions of cloud providers, or special distribution of Kubernetes that provides additional services or additional functionality. And that's where it actually becomes a lot harder to switch, and the lock-in is created. They're, in this case, a big technology company that provides an IoT service to end customers, use the Kubernetes distribution of a large vendor that actually provides a lot of, let's say, add-on functionality. But it's a proprietary add-on functionality. So what they actually found themselves in is a very tough spot, because when they actually had some downtimes, the longest downtime being more than 48 hours for a consumer application. That's like, it's a nightmare. And they actually wanted to switch. They wanted to switch to a service. And what they actually found out is that they used so much proprietary functionality that it would take ages to actually nearly rewrite major parts of the software to actually make it run on an open source upstream Kubernetes version. And the management didn't want to invest time and money, so they were basically stuck with the vendor and had to move to a pricey premium support model. And in this case, if you're fine with that, if you actually go, like, I've met companies that say, well, yes, we actually know it's a lock-in and we actually want to go into that lock-in. That's fine, because it covers a lot of the pains that we currently have. But be aware that there are, let's say, you actually might need more flexibility, alternatives to choose from, because not always the provider that actually is at hand provides the best service or the best technology, the best functionality now and in the future. So if you want a choice, then think about building this up in a very modular way, so you can abstract away a lot of, let's say, proprietary settings, and make sure that the dependency doesn't grow too high. And naturally, are you open for change? So you don't need to go on every latest technology, and don't need to be totally obsessed with changing the elements around. But if you actually run into repetitive issues, it's worth a try. So in a large telco company, I think we've got many telco companies, but they actually are using Open Policy Agent for some time now. And while the configuration is quite powerful, it also can sometimes break clusters. And Opera tries to monitor everything. So if a response is delayed, the framework is very tight. It may block the API, for example, for an API call, and create cascading issues by overblowing the OPA. So basically, that's where you've got a situation where your cluster is majorly impacted, and there are alternatives out there, like Kubernetes, for example. It's a tool they're currently considering. First of all, it's actually more easy to describe, so it's less prone to errors. You can use YAML as you're used to with Kubernetes, and also it's different from their approach, and you actually, it can also be very powerful in that respect, that they can also pre-configure elements in this way. So you can actually then set up, well, I want to spin up this new pod, and it actually should assume following role. It takes time to find alternatives. What I can highly recommend is really take that time, provision in time to actually look for alternatives, and to really think about how do you then optimize your routines, and if something, even if something works, it might not work perfect. Really address the issue very, very early, because if you actually go down a certain route, it's an investment, and that's something that if you actually don't save time, spare time for this, then you actually will, it's something that actually will fall onto your feet later. So now finally, hopefully for the last 10 minutes, we'll actually focus on the operations. So Kubernetes actually has a lot of surrounding technologies that help the development teams focus on their applications. Again, here, actually, I don't want to focus too much on Kubernetes. They're like, the Kubernetes stack is pretty automated. If you don't have automation around it, well, then I guess you need to build it. But there is like a lot of interaction that actually happens between the Kubernetes stack, the apps on top of it, and the needs of the developers for their specific apps that they develop. And also here, the line blurs between what teams need to take care of themselves, and where you as a platform team can really provide a lot of value. And in this case, it's around actually monitoring. This is another telco company that's basically running a vendor solution. The vendor also manages that solution, but on top of the telco's company's Kubernetes environment. And so the question is, where does responsibility start and where does it end? Naturally, you could say, well, the Kubernetes API is what I provide. The rest, the vendor needs to take care of. You might not feel responsible for the workloads running on the clusters, and there's little you can do without the team. You actually need to set up monitoring. You need to set up the thresholds. So there's nothing much you can do in respect to a specific application. But what you actually really can do is set up the monitoring environment and the observability environment in a way so that the teams can easily consume it, and you actually can then build up an infrastructure that monitors that too, so everything stays up and running. And in this case, the company actually went out and looked at the Kubernetes and what was running in the Kubernetes clusters, and they actually found out that while the vendor was supposed to actually to operate their software, they basically found that the monitoring system actually wasn't running. And the vendor actually assumed that everything was fine because they didn't get any alerts. It actually might sound ridiculous to some extent, but it's something that actually just happens on a daily basis with organizations where there are, like, say, areas of responsibility, and you actually need to make sure that you create an overlap. So you actually always have a shared responsibility. But in this case, it's something that you actually, as a platform team, can provide to many teams, and observability or monitoring initially, and then potentially observability later, including tracing, where you can then go out and find problems very easily, and set up alerting and work together with the teams can actually really help you be very successful as a company. And I think this is something that you need to consider and also have time to do. Yeah, this one is actually like an obvious one after what happened to OVH just 2 weeks back. Interestingly enough, it triggered a lot of discussions with many companies. They actually basically thought about, well, what does our backup, disaster recovery, or failover solutions look like, and how can we basically implement it and test it and automate it. And in the case of OVH, you would say, okay, well, one data center went down. Well, guess what? Rust, for example, the multiplayer game, lost nearly all their game and player data because the backup was also affected. And we actually have seen this happen quite some time, not only with data centers going down, that's really a rare occasion, but with let's say technical failures like, broken internet connection, cyber criminal incidents, where companies actually had to take their whole internet communication offline, their whole company offline. And that actually can just have a massive impact. So if you're actually really depending on consumer interaction to generate your revenues, this is where companies are actually looking ways to really stretch across multiple clouds, declarative infrastructure, and automated failovers. And this is something where, let's say, priorities, actually, if these events happen, the priorities shift. You actually need to have time to take care of that. You naturally can say, well, as OVH did, it's like, yeah, you're responsible for your own backup. But like having the teams take care of that is probably makes less sense than really doing that centrally. And that's where you can provide a lot of value to the organization as well. Yeah, and then the question is, as you probably will have that as a top priority, is automation the top priority for you? There are many tedious tasks associated with Kubernetes. Luckily, many of them actually are covered by operators, and can also be automated by scripting. But it also requires time and priority to get down to that, and less risky one, but because you can do it manually. But there are certain elements, like in this case, a large telco company. We actually they actually manage the management of their container images was delegated to a team of people that actually basically got the instructions to delete something, to remove the images, and they basically didn't know about dependencies, so they actually removed it, and then suddenly we actually got called because it actually deleted an image that was still needed. And if you actually want to start a new pod, then naturally you need that image, and that actually is where it becomes really, really challenging, and a lot of manual effort, about 2-3 hours manual effort to bring it back. So what we actually do is every time things happen a second time, we basically make sure, like, if it happens the first time and we think, oh, well, there's a great risk of happening again, we'll automate it. What we actually do is, every time it happens a second time, it's definitely a good candidate to be automated. And that's what you should be thinking about too. It's actually a lot faster and cleaner and safer to do things than doing things by hand. And and then you've got 2 more. One is it's one more. Is it worth a new feature worth the effort? That's actually an interesting one, because I actually would really it's one of the very few use cases where Istio actually provides a lot of value. So I'm not saying they did anything wrong, but it's something that you just need to keep in mind and need to think about. And you actually basically need to think about if a request from a development team is that urgent at all, and if it actually needs to come to that priority, if it actually can be solved very, very differently. And if we actually implement a functionality and it's not used, then we basically plead guilty. This shouldn't have happened. And so we actually basically started thinking about this and going through feature requests by asking basically 5 times why. So really understanding what customer wants to achieve, what is the goal, what is the challenge, and see how it can be best solved in a repetitive fashion, so that it actually can be available to made available to all internal customers. And that's something that is not too much in the nature of a platform team, thinking about the platform as a product, where you basically need to make these tough choices. And typically, if a project needs something, you actually want to support it. But that actually makes your life a lot more difficult. And that's something you need to keep in mind. And in this case, it was a knowledge company that wants to protect their intellectual property. So they actually made sure that every communication happening was highly secure, and they introduced Istio as a service mesh. And over time, it turned out to be a real monster. It required them 3.5 people full time to take care of just managing Istio. And while it might be a good idea for the company, as I said, it's like, it's not, I don't want to criticize that. It's just something that you need to think twice if you actually really, if the value that you see in this area is so high that it actually makes sense, not only to invest the people, but also the additional overhead in terms of risk, in terms of resource consumption and so on, to basically solve that problem for them. And here it's actually really, until you haven't fully understood the problem, you actually need to keep looking, keep asking, and and drive the transition forward in the organization to make sure that it's something that you actually that provides value to your organization, and and helps you evolve in terms of revenue, in terms of innovation, and also makes naturally your internal customers happy.